In this video we are going to talk about definition of derivatives again, and this time we are going to look at square root function, and this is actually example 2 of definition of derivatives. In our previous video we have seen the definition of derivatives as such: f dash of x is equal to limit as h approaches 0 of f of x plus h minus f of x, everything divided by h. Now this is a very important formula when we are looking at definition of derivative. So I would suggest you can take note of this formula, because we are going to use this formula when we are going to differentiate our function. Now, as I've said, that example 2 focuses on square root function. So we have a function f of x is equal to square root of 2x plus 3. Now you can see that 2x plus 3 is inside the square root. That is why this becomes a square root function. Now we need to differentiate f of x. We need to find f dash of x. That is how we denote differential of a function. So f dash of x, here we have f of x, so the differential of that will be f dash of x. Now in order to find f dash of x, this is the formula that we are going to use. As I have said earlier on, that this is a very important formula when we are looking at definition of derivatives. So limit as h approaches 0 of f of x plus h minus f of x divided by h. And this is where we use f of x plus h. Wherever I see x in my f of x function, I'm going to replace that x with x plus h. So this is what I'm going to do next. Limit as h approaches 0, it's from here. Limit as h approaches 0. This square root is all of this square root here. This 2 is here. Instead of this x, I am putting x plus h. So that is the meaning of f of x plus h. Wherever I see x, I replace that x with x plus h. That's the basic meaning of f of x plus h. Wherever I see x, I replace that x with x plus h. So that is why we are saying 2 into x plus h. 2 into x plus h plus 3 plus 3. So this becomes 2 into x plus h plus 3. Minus comes here, and f of x, what is f of x? All of this. This is f of x. So that is why we are putting minus root of 2x plus 3. Everything is divided by h. We have just replaced everything according to this formula. Limit as h approaches 0. This portion is f of x plus h, minus is here, f of x is this, and this h is here. So we have actually just replaced everything according to the definition formula. Now what we are going to do, we are going to simplify this. So this part here we are going to expand. 2 is going to go inside here, 2 is going to go inside here. So that will make 2x plus 2h. 2x plus 2h plus 3. That is what we are going to see here. 2x plus 2h plus 3, and the square root. This is the square root. minus 2x plus 3 over h, which is just here, minus 2x plus 3 over h. So all this part is basically a result of expansion. Furthermore, what are we going to do now? We are going to rationalize the numerator. So this is 1 square root, you have a minus operator here, and you have another square root. So what we are going to do when we rationalize, we actually multiply both the numerator and the denominator by the conjugate of this numerator. Now when we say conjugate, we actually change the sign that separates a and b. So let's call this a and let's call this b. Now if I want to write the conjugate of this, I have to change the sign that is separating a and b. So the sign that is separating a and b here is negative. So when I will multiply both of this by the conjugate of the numerator, I am going to actually change the sign of this. So this sign will now become positive. That is what we are going to do now. So root of 2x plus 2h plus 3 is here, and you can see in place of negative now we are putting positive. That's what conjugates do. And similarly we are going to multiply this denominator by the same thing here. So there you go, you have root of 2x plus 2h plus 3 plus root of 2x plus 3. Next we are going to simplify. Now clearly observe that the top part here can be written as difference of two squares. This is same as a minus b. This first root we call it a, this second root we call it b. So a minus b, and it is multiplied to a plus b. Let's call it a, call it b. So a minus b, a plus b. So when we have something a minus b into a plus b, that can be written as difference of two squares. And difference of two squares is a squared minus b squared. So a minus b into a plus b is same as a squared minus b squared. So that is what we are writing here, a squared minus b squared. So all this, instead of expanding, we are writing in terms of difference of two squares. So a squared minus b squared, and the denominator we are going to actually expand. So h multiplies with root of 2x plus 2h plus 3 plus root of 2x plus 3. So that is what we doing here now. H is multiplied to all this. That is why h is outside here indicating that it is multiplied to root of 2x plus h, 2h plus 3 plus root of 2x plus 3, and this is written as difference of two squares on top, the numerator. So you know very well that the square root and squared are enemies, they will never coexist. So what will happen now, this square root will cancel the squared, this square root will cancel the square, so both of them will go away and only the brackets will be left. So the square root and the square will go away eventually. That is what we have seen now. 2x plus 2h plus 3 is here now, this minus comes here, and 2x plus 3 is here now. The square root and the square goes away, the square root and the square goes away. At the denominator we still have the same things because we cannot do much currently, so h is still multiplied to all of this. Next we can open this parenthesis. This negative 1 can go inside here, this negative 1 can go inside here. This minus indicates there is an invisible 1 here. So let's further simplify that. This 2x comes here, this 2h comes here, this 3 comes here. When this minus goes inside, this becomes minus 2x. When this minus goes inside here, it becomes minus 3. So we are no longer having parentheses, right? We are no longer having parentheses now. The parenthesis is gone. So the top part is now without the parentheses, and now we can actually cancel things. You can see this 2x minus 2x, you can see plus 3 minus 3. So eventually they will cancel out, and the bottom part we are still writing as such. Next we are going to cancel things. Okay, it is already cancelled. So 2x minus 2x plus 2x minus 2x, we can cancel that away. 3 minus 3, they will become 0, so we cancel that. So only 2h is left on top. That is why we are writing only 2h here, and the denominator part is still carried forward from the previous step. Here you can see from here we are just taking the same things in each step. So nothing much is done to the denominator, it is still carried forward and it is still coming up till here. So we are left with 2h and h into all of this. So now you can see one of this h and one of this h will cancel away. This h and this h can cancel. That is why we are cancelling that. We are just left with 2 now. 2 over all of this. Root of 2x plus 2h plus 3 plus root of 2x plus 3. Now what we can do, we can actually substitute our limit. Our limit is h approaching 0. So whenever I see h, I can replace that h by 0. So this is what we are going to do. 2 over root of 2x plus 2 into 0 plus 3 plus 2 root of 2x plus 3. So 2 times 0 becomes 0. So this will be 2x plus 3 and 2x plus 3. So whenever you have a 2x plus 3 plus 2x plus 3, those are like terms. So one copy of 2x plus 3 plus another copy of 2x plus 3 becomes 2 copies of 2x plus 3. Remember, this part here becomes 0, so it goes away. You are left with only 2x plus 3 and 2x plus 3. The square root is still there. Square root of 2x plus 3, square root of 2x plus 3. So when you have 2 copies of 2x plus 3, this is how we denote 2 times 2x plus 3. Okay, so we have 2 here, we have 2 here now. So that will eventually cancel out. They will go away, right? This 2 is going to cancel with this 2. Remember, 1 is still left here. It's not 0. Many people, they assume 0 is left after this 2 goes away with this 2. Many people assume that 0 is left here. No, this is 2 multiplied by 1, right? 2 can be written as 2 multiplied by 1. So that is why always 1 is still left after cancelling. So when this 2 goes away, this 2 goes away, 1 is still left here. So that is why our final answer becomes 1 over root of 2x plus 3. So this basically means whatever we started with here, root of 2x plus 3, we had to find the derivative of this. In other words, we had to find f dash of x. So when we find f dash of x, this is what we did. We used these following steps. The main thing was the f dash of x formula, right? Or we call this definition derivative definition of derivative formula, sorry, definition of derivative formula. This is very important, and these are the following steps that we used in order to arrive at our final answer. Okay, so in my next video I'm going to upload about other functions such as polynomial and or maybe quadratic or linear function, and I'm going to use definition of derivative to explain how to differentiate a particular function.